drugs.
Sure, of course. But I haven't been hacked. Yeah,
Almost just as bad.
it's pretty much, it's pretty bad. It's a pretty bad feeling. Yeah, there was this game I thought was gonna be awesome. It was like a first person RPG. I like bought a bunch of tokens, I was invested, and then one day the guy just, everything was gone. Everything was gone.
Oh, that's so tough.
Oh, it was
They
sucked.
just red camera.
It was not good.
I'm waiting for our president to run full his. I made some good money on the dunk course this weekend.
Really?
Oh yeah. I got in early. And I sold pretty early too, before it crashed.
Oh yeah, before it was.
What was that?
Oh, I said I can't wait for our president to run full us.
Don't get 'em
I
fired up.
avoided all of that. Like I said, still apes in many ways. Crypto apes. All right, my friends. So let's see, what's going on? Where's Othman? Fashionably late. Othman. When you watch this video. Okay, so I don't know how the pre-quiz went. You either remembered about it, I only reminded you 10,000 times, or you didn't, and it's okay. There's room to slack and miss one. It'll happen, you know. There is one for Friday. So if you also saw, I moved the skills check to Monday, which is good for some people, Christian in particular. What's that?
I was planning to be here on Friday.
Oh, okay. Okay, well, cool. It's even better. That's great. The skill checks will go even better. So
You remember what those are again? The skills check? Is that-
there's a quiz in world class that's either you did it on before class or you didn't. And it's like you go and it'll say read this section, work through this exercise in the book, and then I give you a couple problems. This one was super, they're gonna be super easy. This one was interest. Just use an interest formula. Put that in your calendar. You'll see them in you'll see them in world class. There'll be reminders. They're quizzes in world class.
So what was the one that you were talking about that was that you gave a thumbs up or?
That's that one.
Oh.
That's you did it before class, so you did.
Oh, okay, so that's that.
Yeah. Yes.
Was it just to see if we could open the ebook?
It was for a lot of things. Yeah,
See if you're paying attention.
pretty much. Because it literally took the fact that you're in this class, it was not exactly. It was, can you open the read book? And you learned to read somewhere along the line, I'm sure. And
Good, we did it right. Yeah. Chris and I were worried we were missing something.
Yeah, I know.
This
It was
cannot
way
be
too
this
Oh,
easy.
God,
It
no,
was
no, this was
You're talking about it. It was
replace two numbers in the formula and redo the
They didn't even have to
PERT.
rearrange the formula. It was just perfect.
It was yes, everything was just as Eric said,
Was it mine?
are you awake? Are you awake? It makes you look in the book. Now the next one, you'll have to read a little more. So don't wait till you'll have to read slightly more for the next one. It's on vectors. Or whatever, yeah, however you do it. Have ChatGPT read to you. It's I don't want to read this. Tell me what it says.
Give me the key points.
Give me the key points.
Give me the question answer.
So I'm not gonna go into other methods. You'll figure them out. You know more than I do. Cool. So yeah. So there's one for Friday. There's not one for Monday then, because Monday's gonna be come on in. I've got 2 skills checks that you could probably get done in that time. Maybe 3. I doubt it. But you can get as many done as you want to get done in that 75-minute class period. Yes, sir.
Is the web work considered just practice?
Yeah, well, that did count as, I think I said that counts as one of the skills checks, you did it or you didn't do it. Is that a good answer?
I think so.
Okay, cool.
Figure it out more.
Yeah, it's as long as you tried, I was sure, that's good. That's good. That was to see if you could open the web work. But it was way harder than the quiz. Way harder. Any other questions, my friends?
Do we know what the school check on Monday is going to consist of?
It's going to consist of basically stuff we do today and Friday. Does that sound okay? Yeah. So what are we doing today? We're starting functions of several variables. We're gonna do a brief intro. Corey, you've been doing some good faces today. We've got functions of several variables, bit. We're gonna start vectors then. And so maybe I'll start that today, and certainly Friday will be all vectors. How many folks have seen vectors in 2D? In 2 dimensions, yeah, and in the plane. How about in 3D, 3-dimensional vectors? Okay, cool. All right, we're gonna review a lot of that stuff. I couldn't tell if your hand was, no, okay, cool, we got you covered. Awesome. And then some basic linear algebra at some point, but nothing heavy. All right, cool, well, things get fun today. Let's talk about functions, purple. Functions of several variables. Cool. So, just recall functions of one variable. We had an output and an input. So we had one input and one output. Independent variable, dependent variable. Maybe Kayla said that or something, but yeah. So we call that independent and dependent variables. This one depends upon that one. This one is free to do as it sees fit, like we are. And look what we do with it. So, functions of several variables is I've got an expression, a formula, but it depends upon 2 things perhaps. So I've got 2 inputs here. 2 inputs, x and y. These are 2 independent variables. They may or may not have restrictions in the same way that this has a domain. And remember that a domain is equal to all legit inputs. And legit could be, no one tells you what the domain is, you just gotta make sure you don't divide by 0. Or the domain is restricted because this represents some specific range of temperatures or measurements, or there maybe are natural restrictions that create a domain. And same way here, these could be free range variables, x and y could be anything you think of, or they might be restricted. And then we have an output, which we call z. And was it, Zara, was you pulled a z out once, and I said, let's hold on to z, or was that Eric? I can't remember, we came from this corner of the room.
Maybe it was.
Yeah, okay, cool. Well, you had Czar, we'll just go with that, Z, yeah. So we got one output again. And we are not going to deal with multifunctions in this class for a while, but eventually. So a multifunction is where you've got multiple outputs as well as multiple inputs, or maybe even just one input. But for us, we're just gonna have one output for now. And then this can extend to as many variables as we want. We could do x, y, z here, and then I have a w output, and I can keep on going, but this becomes cumbersome. And maybe you're doing like a neural network or something where you have billions of variables here. You know, some OpenAI stuff where there's so many inputs, I run out of 26 is not enough. So another way we could do this is we could index the variables in this way. And I could go up to x sub n. So here I have n inputs. And then some output over here, we could call it whatever. It could even be y, but I'll just say z here, one output still. And you had a little warm up with the PERT formula, right? The, I can't quite remember. Yay, there it is. With the amount in your account that has a principal balance of P. Oh no, shit, I thought that was, okay, oh! They're so clever. Wasn't off one after all. the formula was something like this, right? Except,
Wasn't R like 0.05?
yeah, exactly. So this is your interest rate. This is for continually compounded interest, which is like a dream that never actually happens, but, and this is time. And this function here, they fixed R, but this could have literally been a function of three variables, P, R, and T as well. But they fixed one of them, but it could have been a function of three variables. When I was talking, I thought it was Atman coming in. I was all excited.
I don't think you'll be here today.
Okay. Interesting. All right. So this is good enough, but we want a picture. We like pictures. Pictures always help the brain, right? Like when you think about a function, thinking about how it acts globally. If I see this, I know something profound about it. Whereas if I saw this, which is pretty much the graph of that, might as well make it legit. -1, 0. If I see this, I can do stuff. But if I see that, I understand a behavior. I understand that it's got a maximum here and a minimum here, and it crosses 0 at those places, goes to infinity, goes to -infinity that way. So the picture, worth literally a billion variables. When we come down here, things start to get interesting. So instead of an X input, a single X input, we have a plane worth of inputs. And we want to show that if I plug in this value here, say -2, 4, that looks more like a 2, but I'll say it's 3. If I put in -2, 3 in the plane, then some value comes out. And as I change this point, the value that comes out over here is gonna depend on the formula, and it's gonna change. So imagine there's another axis coming out this way. And the height of that pen is the z coordinate. So coming out of the board would be positive, going into the board would be negative. Now we're not going to draw anything like this for the most part. We will kind of, in a way, look at something like this, but we need to represent 3 dimensions in 2 dimensions. So we have to lose orthogonality. Right? So here, in this picture, everything's at right angles to each other. These 2 axes are at right angles, and this is perpendicular to the plane. But I can't do that in 2 dimensions. So what we do is we draw a plane that's like this. And I think in our book, we probably make the z-axis up. Here's x, and here's y. And this is a right angle, and this is a right angle here. And you just have to imagine. And this is where the fun comes in, honestly, trying to make these cool pictures, these orthographic pictures where you're trying to represent 3 dimensions in 2. And you either probably are pretty good at that, or it's gonna take some work. And that's okay, we're not gonna do a lot by hand. That's like an old person's thing to do. Like when I did these, we had to sketch them, but now we have Desmos. And Desmos does a hell of a fine job doing these. So I will ask us, we will think about these things, but rarely will we produce graphs of them. Now, when I get down here, good Lord, now I've got 3 inputs. So I've got 3 dimensions. I've got an X, a Y, and a Z, and these are all perpendicular to each other. And I need a 4th one that's perpendicular to all those at the same time. And we enter the 4th dimension. And I can't draw it. We think about it, and we will because we have to. It just sounds like, how can we pass up the opportunity to think about the 4th dimension when we're so close to it? But there is no direction you can visualize that is simultaneously perpendicular to all 3 of these things right here. Imagine they're perpendicular. They're not. There's nothing in this world that we can imagine that is perpendicular to all 3 of those simultaneously. So we don't really mess with this. But we have fun with it, and we go play with it on our own. But here's about where we're gonna land. And then imagine this. What? Fifth dimension, sixth dimension, seventh dimension. Honestly, once you go to the fourth, everything's so freaking weird, you're good. You're covered. So let's think about how we might get a handle on picturing these things. Even though it's really hard to do it by hand, we're still gonna try our darndest to do so. So let's say I have something like this. And let's see what we can do. So there's two main tools, and there's going to be two main things I ask you to do on Monday with this stuff. In understanding how these things might look in three-dimensional space. Now I'm kind of curious if anybody's had experience with this and actually can picture this in their head. Yeah.
I mean, like,
Yeah, what do you think?
usually in like a lot of like physics stuff, you do a lot of wave stuff, and it's like in 3 dimensions.
Yeah. But do you have like, can you picture kind of what that's
Like very vaguely.
Okay, yeah. So let's, same?
Yeah,
Yeah, kind of. Do you have a like, what do you have? Like,
I don't know, I was bored. And I was really into calculus when I took Calc 2. So.
that's called being cool, Kayla. That's called being freaking awesome. Yeah. So you can kind of, like,
Maybe.
okay, all right, I don't want to spoil the fun. Yeah, that's really cool, awesome. Because I was bored a lot too, and I spent a lot of time just drawing these for kicks, because it's cool. So let's talk about some ways we can understand this without getting out Desmos, because we'll pull out Desmos in a bit and check ourselves. But the first thing we could do here is look at what are called level curves. AKA a topographic map. So how many people have ever gone hiking with a map or used a digital app, And you see lines like this, and you're walking, here's your trail, and then on the map, you see something like this. You see gradient lines, and every one of these is, say, like a 6-foot increase. So as I move this way, I go up 6 feet. If I move from here to here, I've risen 6 feet in elevation. And then you see, you're like, yeah, things are pretty chill. What kind of hiking is this? Good, chill, hard? Looks chill, right? I guess it depends on how long this line is, but this looks chill. Because this is another 6 feet here of elevation. So I'm not saying it's 6 feet apart. I'm saying that as I move across here, I'm moving up. So if I looked at the side view of this thing from here, I would go up 6 feet, and then this one here, you would be up another 6 feet. So this is 6 feet like this. And then this trail, kind of just doing something. You're going up. And then you see this happening. What are we approaching? Quite a climb. Quite a climb, because those bands represent 6 feet of increase as I move from one to the next. So these bands here, 6 feet of increase, are coming faster and faster and faster. And that means this trail is getting steeper and steeper and steeper. And the 6 feet still stays the same, but the trail itself gets steeper, so you actually cross those faster. You're probably gonna cross them really slow as you do it. What kind of say I'm looking at a topographical map. Let's look at one. And what if I see this? And let's say each one of those is 6 feet of elevation increase. And I'll give you some lines here really quick. So let's say this is 100 feet, this is 106, 112, 118. What does that look like in the world? Okay, hill, right? Kind of a round hill. Do we see that? It looks like, and maybe if this is actually flat up here, then from the side it kind of looks like this. And here's that top 118 circle. And then here's that 112 circle. Here's the 106. And then here's the 100 foot. So there's 100, 106, 112, 118. So I can take that topographical map and get a mental picture. And this is what we're gonna practice with. These are level curves. That's all this is. These are level curves. Each one shows us where a particular height occurs. And so we can do that with this and gain a lot of insight. And that's what we're gonna do first. Is there any questions? Is this making sense? Good? Yeah. So we have to make our own topo maps, our own level curve maps. And we're just gonna get out an XY plane. We're gonna set different height outputs, Z, and we're gonna see what the locus of points is in the plane that satisfies that equation. So let me show you what I mean. More colors. Paid for these things. Should use them. Yes. Excellent. And I should not let them dry out. So we'll stick with that guy there. So I'll bring him over here again. So here's Z. Z equals x squared plus y squared. I always like calling it Z. All right, so what we're gonna do is we're gonna make a little table. And here's gonna be our Z value. And here's gonna be the plane equation. That's gonna relate x and y for that particular Z value. So let's start off chill. Let's start off chill here. First, I'm gonna let Z be 1. Notice I'm leaving some space here. Leave that, if you're making the table with me, leave a couple slots of space above the 1. So when I replace Z with 1, I get this equation. Now it'll sure help if I know some basic equations. Does anyone know what the shape of that is in the XY plane? I'll start making the plane while you perhaps remember this.
Is it a circle?
It is a circle. What is the radius?
1.
It is, indeed. Let's put that up here. So this is a good equation to know. X squared plus y squared equals r squared. That is a circle of radius r, centered, and we're going to need this, centered at 0, 0. So centered at the origin. So it's literally this shape. Right here, so there's r, minus r, minus r. I'm writing like I'm holding this weird, so x, y. Just drew on my shirt. Luckily it's tied in. Questions, we good? So we're going to come to the plane here, and we're going to make this circle of radius 1 in dark blue. Not bad. And that's 1, 1, minus 1, minus 1. Cool. And what I want to do is also label that. So this is Z equals 1. I'm going to put a little label there. Z equals 1. So that I have the height, the altitude it represents just there, easy to access. What's a good R value to use next? 4. 4. So we'll say R squared is 4, right? So R is 2, and R squared is 4. So now check this out. So if we say x squared plus y squared equals 2 squared, that is a circle of radius 2. Which seems like the natural thing to do here. So I'm going to make a circle of radius 2 as best I can. That's subpar.
Above average.
Thanks. Thanks. I got a C plus on that circle. I didn't realize it's upsetting. I gotta fix this part. Still a little wonky, but hey, All good. So this is 2. 2. This is 2. What's the z value though?
Two. 4.
4. A circle of radius 2 has a 4 there. So if I have the equation 4 equals x squared plus y squared, this is 2 squared equals x squared plus y squared. So it's a circle. At height 4, it's a circle of radius 2. So make sure you're seeing that. So this is z equals 4. This is z equals 4. So as I walk from here to here, it's pretty steep. I've gone up 3 units. Even though it's only 1 horizontally, I've gone up 3. Very steep. What's the next good one? 9. Z equals 9 gives me a circle of radius what? 3. So 9, we get 9 equals x squared plus y squared. Now I could put 1, 2, 3, 4, 5, but then I have to think about the square root of 2 is my radius. The square root of 3 is my radius. And these are a little just nicer to work with. So that's 3 squared is x squared plus y squared. So my next circle over here, still just 1 unit bigger in radius, but representing a height of 9. Let me stop. Can we start to maybe think about what's going on here? How do we, yes, like a cup. At least it's growing up, right? It's kind of like a hole in the ground or something, a sinkhole. This is dented. This edge here is higher, so we've got like z equals 9, and then we come down, and then here's z equals 4. I'm doing my cones better than doing that. It's not a cone either. So there's z equals 4, and then here's z equals what? This is z equals 2. And that's like hollow there. So it's a little bit like a funnel with a big hole in the bottom, but we got to kind of think about right here. What's the least this quantity could be? Oh, that's a heavier question. What's that? Yeah, Kayla, what are you doing there? Yeah.
0.
Why is that? You're right.
Well, if we make z equals 0, then the radius would be 0, so it would just be a point.
Yeah, so let's put that in there. Yeah, so that's why I left a little room here. So when I put 0 in, I've got 0 equals x squared plus y squared. If x is any number other than 0, this right side is positive. If y is any number other than 0, this side is positive. The only point that satisfies this is xy equals 0, 0. Think about it, because you're squaring. As soon as one of these things is non-zero, it becomes positive when you square it. So the only solution there is 0, 0. So at 0, 0, a single point, I've got z equals 0. Height 0. And that means I can bring this thing down to a little point like right there, and there's z equals 0 at the bottom. So it's a little cup shape. What's the next best z value? 16. With 16 here, can you go ahead and finish that up just to make sure your drawing looks good and you're doing stuff without me doing it?
Look at this guy's drawing.
Are you doing you're like using his drawing just like
Pure masterpiece.
telepathically? It is pretty.
Pure masterpiece.
That's pretty sweet. That's pretty sweet. I want to see yours though, Daniel.
That's another information.
Interesting. You'll share that with us on
bored.
Your drawing's very
It tells you everything here.
It does. I told you everything here, your paper.
Yeah.
Next year, we're gonna do one.
It's the key point right
Yeah,
here.
it's a little
That's
bit
right.
dry. I really like drawing the things.
Looking good, looking good. Oh, look at the colors on there, Alexander, beautiful. I like the black background with the green, looks cool. It's like old school CRT.
Yes.
Yeah, but you're not, yeah, you're like, I
I
don't
think
know,
the
I don't know,
black-
Grandpa, I guess it is.
Yeah.
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 I don't know how to use punch cards to program a computer.
Here's some Fortran, going back.
Going back to, yeah. So this is a circle of radius 4. And it sits right here. It's still just 1 unit away. Oop. So you want it to be, these are concentric. That one might be the best. That one's not bad. Oh, is it not good enough for you, Christian?
No, I was saying.
Okay. Sorry. I'm just kidding. Then Z equals 16, Z equals 16, Z equals 16. And this got really steep. Because from here to here, it's 1 unit of increase. I went up a foot. From here to here, I went up 1 foot. Here to here, I went up 7 feet. Here to here, I went up, 5 feet. 9 minus 4. Here, I went up 7 feet. So it's getting steeper all the time as I walk away from the center.
Yes.
Yeah, we good? You see this? Yeah. It's like a nose cone, like a rocket. It's parabolic. It's actually called a paraboloid. And we'll look at another way to see it. So this is how level curves go. Let's stay with the same equation and gather some other information. To make this picture more complete in our brain, we can also do slices. So we can take this thing here and we're gonna well, actually, let's get an axis in here because really what's happening is there's a z-axis right there. And then underneath this is the plane. Positive x, positive y, and you can't really see all that y because it gets blocked by the thing, and then come back here and it gets blocked by the thing just a little bit. But I've got it, this is sitting on a plane. And we have to somehow envision that, right? It's like, here's its tip right here, and then it just rises off. This is the XY plane, it rises up in both directions. Anybody have like we don't have any cups, parabolic cups in there. Like Alexander's is the closest thing. It's kind of like that, but it just balances on a single point. There you go. Thank you for the demo. Yes. All right, so these are called level curves, but there's another vision we can take on here, another way to cut this, and we can do slices with respect to various axes. Various axes. So let's say I have this, C equals f of xy. And so I've got over here my xy plane. See, this is positive. This is positive, and back is negative. I'm just gonna kind of make that dotted. So back there, this is negative, and behind there. So what we're gonna do is we're going to fix an x coordinate at, say, x sub 0. So I'm gonna fix that and look at what the shape is in the plane that corresponds to x sub 0. So think about this. If I look at all the points that look like this, x sub 0, y, z. I fix the x coordinate. The y and z coordinates can be free to range. So this is a plane through the point, let's see here. So this would be x naught, comma 0, comma 0. That's this point right here. So this is x naught, comma, 0y, 0z. Because I didn't move in the y direction and I didn't move in the z direction. So this point right here. And this is a plane through there that is parallel to the YZ plane. Now I'm writing all that stuff and I'm kind of like just saying it and getting to it, but I want you to try to like make sense of it and see if that makes sense. Do the words match what you're picturing? And let me know if they don't, and we'll talk. Boy, it's hard to see that. Yes, yeah, you got it. Yeah. Maybe I'll close this up just a little bit, just to see if it helps the glare. Sorry. Maybe that is that a little better?
It was better.
Okay, sweet. Because it did look, I was rough, especially with the shittiness of this board. Just very crappy. So, what we'll do is look at all the points that in this plane that intersect our actual surface that we're trying to understand. Now let me explain what I mean here. Let's see here, with our given thing. And I think the best way is to just see it with this specific example. So let's look at the slice through x equals 0. So right now, what am I doing? Here's x, here's y, here's z. I'm setting x equal to 0, so there's no x coordinate. That means it's in the YZ plane, i.e. the trace, this should say traces, not slices. That's the word I'm thinking of. The trace in the YZ plane. In other words, when this shape intersects this YZ plane, what does it look like? What is the curve of intersection? Equals curve of intersection of surface and YZ plane. So I'm just going to set x equal to 0 and look at this. So if I set x equal to 0, the equation becomes z equals y squared. That is a parabola, right? If that said y equals x squared, you go, parabola. Everybody knows parabola. You know parabola, right? Everybody knows parabola. So this is a parabola in the YZ plane. And I'm gonna actually, before I get fancy and put it up there at an angle and try to represent dimension, I'm just gonna look at it here. Here's the YZ plane. And this thing looks like the old parabola with vertex at the origin. That curve there is where this purple thing is intersecting the YZ plane. So you'd see that. I'm cutting it. I'm just cutting the cut. I'm just cutting it right parallel to the YZ axis. And I see that blue parabola. And here's the side view, right? And when that picture there, I'm looking down the x-axis at it. I'm literally lined up on the x-axis looking down it to see what shape I see. So it tells us that the side of this thing is a parabola. Just further cementing what we understand about it. So similarly, we can do this with other planes. If I do it through, oh my God, it actually can erase. It's just so freaking hard to do. I didn't buy my clock. Should have bought my clock. So let's look at the trace through. See, what do we do here? X equals 0. Let's do x equals 1. Now the x equals 1 trace corresponds to 1 on here, and it's gonna be parallel to the YZ axis. So imagine a slice through x equals 1 unit this way, parallel to the YZ. Can you picture it? Take a minute, picture it. Maybe draw it. Or look at Christian's drawing of it, I guess. Imagine just cutting that straight down with a knife. What does it cut? And draw it in the YZ plane. If you're looking down, the x-axis at it, what does that slice look like? So remember now, you're just gonna plug in. Take that x and you're gonna replace it with a 1. So it's z equals 1 plus y squared. That's this parabola, shifted up 1 unit. Does that make sense? Yeah, so like some basic graphs, you're gonna need to know some basic graphs in here, and you, honestly, you should. Circle, I'll give you. You might not be as super familiar with that, but parabola, you know parabola, and I don't wanna hear otherwise. So here is the vertex at 1, 0, and it looks like that. So this is the x equals 1 trace. And that out here looks like this. It's fun to draw 3D. It's just cool. All right. What is the, can you do a couple here for me and just see what you see about them? Could you also do the x equals -1 trace? Picture it like this. Picture it up here. And then could you do, please, the y equals 2 trace? So now I'm telling you to do the y trace out here. And that's going to be parallel to the xz axis. So here's y equals 2. What is the trace? So this is parallel to the xz plane. Just do your best. That's honestly all I ask. Just try some. Try anything. New colors. That'll help. I know about that orange. I'm sorry. It is Jordan almonds.
Jordan almonds.
Want one?
It's a Jordan almond.
You're allergic to almonds? I'm not going to jail.
I'm not almonds.
I don't know if I have enough for everybody, but I'll bring more tomorrow. I don't know, maybe for everybody.
What's that again? Are they Easter eggs?
Exactly.
They're not Easter egg. They look like Easter candy. It's
It's just like-
because
that
they're
was
like.
pretty good.
almonds.
This fucking thing?
No.
Maybe.
The macaroni.
Ooh,
They're almonds. These are nuts. If you're allergic to nuts, don't even breathe.
thank you.
Thank
I
you.
appreciate you.
Oh, I don't know. That seems crazy to me. I don't like it. Really?
Oh, wow,
Nuts and candy for
I'll
me?
get
That's
tried.
sweet. Thanks.
Okay,
They're
cool,
good.
cool.
They're very
You know
sweet.
you. I don't know what you got.
Like caramel sweet?
No, like.
Artificial sugar.
Like-
I just like how you looked at it. You're like, nah, I'm good. Did you get one, Eric? You want one? Sure. Cool.
They're good, but very sweet. Wow, that's like.
What do you think of that?
I pulled out like
I got no
bizarre memories from like Easter
I am
from like.
freaking addicted to those. I
decades.
just honestly, I do like, wow, go, cool.
It's too sweet.
Oh, well, they're horribly sweet.
It's too
I
sweet.
can't stop eating them. Go to Vitamin Cottage, buy like gallon bags of them.
The negative one?
I think you can pick the next like 4 weeks.
That flavor, there's just that unique flavor.
It is unique.
Yeah.
It is definitely.
It's not bad.
Yeah.
I just like smell that
I don't even smell like anything.
Fair enough. I think that happens. I think you're not alone. By the way, thanks for making me not write one more. Okay, you're welcome. I appreciate it. I would have clapped
Because
for
it's
that.
negative one, or I guess, well, yeah,
It's like-
positive X.
Yeah.
Yeah, so then.
I can help, yeah.
It's truly, it is a help. I got a bunch of them I need to get.
Yeah,
So
right,
shit.
right, right. I mean, that's kind of what I do, bro.
Not much good.
I don't think
But I had to get.
that you can do it.
Absolutely.
I am a person, no. No, me and 3, we got 3, Stay there for
You're close.
People had to go rinse their mouths out. People had to leave and like, wow, God, I'd go eat some fish or something.
I used to like almond joys at
Why
first. I was
fish?
excited.
How does that?
Why fish? Because it tastes terrible. Because this tastes so terrible, you would want to eat like smoked herring or something.
It's like an almond choice, like it's like a single.
So the x equals -1 trace looks like the x equals 1 trace. We good on that? Cool. So that this covers both of them. And when you think about what this thing feels like, it looks like that makes total sense, right? It's just a cut in the back here. That goes, where's my greenie? Share my old man candies with you guys again. So, it's in the back there. Kind of comes up like that, and it's yeah, kind of in the back. It's hard to see. Hard to see. Then let's do we still need a little more time on y equals 2? Because it's a parabola again, right? At y equals 2, we expect this cut to be a parabola. Look at that, that thing's, there's symmetry going on there with that x squared plus y squared. So when we go to y equals 2, the only difference is it's in the y equals 2 plane parallel to the xz plane. So y equals 2, I've got z equals x squared plus 2 squared. The y is replaced with 2, z equals x squared plus 4, and it's just in the x and z world. What we're gonna find out is somebody didn't know they were allergic to almonds, and then, yeah.
Let's see.
4, sorry.
See?
Yes, thanks, sorry. Yeah,
I got you.
you got it, cool.
No context for that.
So I'm gonna draw it in pink right here, and it sits kind of orthogonally. It's way up here though, right? It's kind of just the tip of it can be seen right above there.
You wrote 2 again.
What's that?
You wrote 2 again.
Did I?
Yeah.
Where did I write 2 again?
Is it not
Well, this
one?
is 2,
Okay.
because this was y equals 2, but it produced a 4 here, so the height is 4. But this is corresponding to y equals 2. So I stand by my 2, that 2.
You didn't get it right. It's right here.
It looks good. I think you got it right. Looks great.
Yeah. Wait till you look at it.
Yeah, I haven't looked at it, I guess. Is this good?
Perfect.
All right, let's have fun. Your turn. Let me give you, I would recommend traces first. Unless you are familiar with graphing hyperbolas, which I'm suspecting not. So I'll put a little info up here about hyperbolas. While you do traces, get some traces, that's gonna help a lot. See what you can come up with. And if you need guidance, oh, this pink is really nice. So you're gonna do x equals maybe 0 and 1. Maybe -1. See, once you got that, you got the other. And I would also recommend y equals 1, 0, 1, and -1. And see if that gives you an idea of this surface.
We're just changing the function to be x squared minus y squared.
Correct, yeah, I put a minus in between those two.
No, it's in, it's under sheets where it's like that, I think. Because the X part is like pulling up and the Y part's pulling down. I don't know if I can draw that though.
Is it like 240 or something?
252.
252, wow, way off, thank you.
Let's go.
Start with 05.
I'm gonna come check your drawing now, Czar.
Oh, really?
Yeah, after that.
You gotta do that. Three cartons, three.
It's collaborative two sheets is what it's called, I think.
That's it, I'm ordering a rag.
WD-40.
What's that?
WD-40.
Is it
And grease the board.
It's the sound, yeah, maybe that would make the sound less squeaky.
Order a new board.
New board.
Get it, put it in your
Put
pocket.
it right there.
What's that? Oh.
Unless I have no idea what I'm
Yeah.
doing, also just keep making sure.
Oh my god, that's so much better. Come here, come here. Awesome.
Yeah, this is what I was thinking.
You kinda still hear it, but at least it's more
X goes
effective.
down, the Y goes up. I don't really know. Or I guess that's but the opposite.
Oh, lost the equation.
Because it would be like the Y goes down, and like the X is curved up.
And like, yeah, I'll get you some level curve help.
You're right.
I think music was.
I don't agree.
Together like that.
Mm. Okay, so do that. But R is not 0. There we go. This will be helpful for the level curves. That down.
Yeah, mine doesn't look anything like that, so.
It's pretty.
I don't know how you do that.
It's beautiful. Oh, thank you.
Put that on the wall. Frame it up.
Frame it and put it on my fridge.
Local museum.
Those are the two basic hyperbolas. Symmetric hyperbolas centered at 0. The asymptotes are y equals x, y equals minus x. No matter what r is, the value out here controls where the vertices are. So the larger this r is, the further away this little box, this black box gets bigger. And if it's x squared minus y squared equals a positive thing, then that is open sideways. If it's y squared minus x squared equals a positive thing, it opens up and down. If like all this is like, duh, then I would ask you, when r equals 0, what does it look like? I'll put that up here as a little bit of fun. So when I have x squared minus y squared equals 0, what's in the xy plane satisfy that? X. Because look, at factors, the left side factors. Or x equals plus or minus y, you could do it that way. So you could say x squared equals y squared, therefore x equals plus or minus y, but here you also get x equals y or x equals minus y. And literally, it's these asymptotes. It literally becomes those asymptotes. You can think of it as letting r shrink. As r shrinks towards 0, these corners come in. And then when they touch, these become perfect diagonal lines. So, see that? Yeah. So these look like this. And knowing some of these basic conic sections like parabola, circle, hyperbola, they're good for you. They're good. They come up, gives you intuition you wouldn't have had otherwise. I'm not looking at anybody's drawings, so unless you want me to look at your drawing, I'll be happy to look at it. But I'm trying to like lay off the people being concerned I'm judging their drawings. So, did we get these traces knocked out? What do the traces look like? What parabolas? Those are parabolas. So let's do these together. So when x equals 0, let's do the x equals 0, 1, and minus 1 traces. So these are going to be y, z, planey kinds of things. When x equals 0, and you should write these things out to help your brain. I've got z equals x squared. Oh wait, z equals y squared. Okay, z equals minus y squared, good to God. When x equals 0, it's z equals minus y squared. So what kind of parabola is that? Does it open up or down?
Down.
Down, yeah, so it looks like that. So that is x equals 0. When x equals 1, I get z equals 1 minus y squared, which probably is easier to think about like this, now that we have z equals y squared. What does that do to this parabola? Shifts it up 1 unit. It's going to make the vertex 1. So that's x equals 1. What about x equals minus 1? Up 1 unit as well, right? It literally overlaps with this one. So this is x equals 1, x equals minus 1. So think about these slices. At x equals minus 1, which, so let's say my head is like 0. Behind me is a parabola that's up. As I come to 0, the parabola drops down. And then as I move this way, the parabola goes up. So I'm seeing parabolas, my arms are the parabolas, that go like this. So I'm getting some intuition from that. So here again, I get that same equation. So from those traces, I'm picturing this. I'm picturing this motion. And then I go to do the y stuff, and it's the same thing, just in the other direction, but what's different about those parabolas? They are upward parabolas, exactly. So when I do these guys, when I do y equals 0, then I'm in the xz plane, because y is fixed, x and z still free. Y equals 0 says z equals y squared. X squared, excuse me. So that's this guy. So that is y equals 0. And then when y equals 1, or plus or minus 1, we get z equals x squared minus 1. So it drops. So there's y equals plus or minus 1. So these parabolas, the one back here is low, it's below the plane, and then as I approach 0, it comes up, and then it comes down. So in one direction, I've got parabolas moving like this. Down, up, and in the other direction, and that's this one here. And then in the other direction, I've got parabolas moving down, up, then down. So like that. Weird. But it gives me some intuition. But it's honestly not until we get these level curves knocked out that we can kind of really see what's happening. Has anyone got level curves sketched on this yet? No? Okay, let's do, what time is it? 3:04. We gotta get these level curves finished. So here, like honestly, make sure you have this. You are going to need this information along with the parabola stuff. Like it's gonna come up. So let's put together, let's get the level curves out because they're gonna be parabolas or hyperbolas. And then I wanna talk about conic sections and we'll call it a day. Because conic sections are cool. And it'll make this all, you'll see the whole view of all this stuff. So z equals x squared minus y squared, level curves. And here z can be positive, negative, all sorts of stuff, doesn't matter, it doesn't have a restriction. Because I can make it as negative as I want by making y big enough, and I can make it as positive as I want by making x big enough. So no restrictions on z. Let's first look at z equals 0. Always a good place to start, nice low hanging fruit. So these are going to be in the xy plane. Those are always in the xy plane, these level curves. We're looking down on the surface, making a topo map, so we can plan our course. I'll do these in green. So when z equals 0, I've got x squared minus y squared equals 0. That's x equals plus or minus y. That is literally diagonal lines. So on these diagonals, the height is 0. That's the only place the height is 0. Let me stop. Is this making sense? Make sure you're with me. Then we're going to do z equals 1. When z equals 1, I've got x squared minus y squared equals 1, setting the z equal to 1. That is, notice how the x squared is the positive. That fits into this with r equals 1. It's hyperbolas opening sideways. 1 unit, with vertices 1 unit away. So here is 1, here is minus 1. Notice that x equals 1, y equals 0 is on that curve. When x equals 1 and y equals 0, or x equals minus 1, y equals 0, that works. And then this acts asymptotically. So this is z equals 1, and so then this is z equals 1, and I start to, it starts to become easier once I get my bearings. And this is, I'll put ones and zeros, so there's a 1, there's a 1, because this gets confusing. 0, 0, 1. Taking our topo map. And then when x is 2, our z, let's say z is 4, look at the way I did that. It's like a circle. It's very much like a circle. I'm going to take the square of the radius. So when z equals 4, I've got x squared minus y squared equals 4. Notice that when x is plus or minus 2 and y is 0, that works. So I've got 2, 0, and then a hyperbola. And I've got minus 2, 0, and a hyperbola. What's the next good z value? 9, indeed. When z equals 9, we've got x squared minus y squared equals 9. That has x plus or minus 3, y equals 0 on it. So it goes right through 3 here. And it's this is going to look bad because this should get asymptotic and things are getting really far out. So that's 2, that's 3. I'm going to take these units off because this was level 1. This was level 4. This was level 9. So that's moving up. This was level 1, level 4, level 9, moving up. So I'm standing here in the middle where it's ground zero, literally. And as I look that direction, things are rising up. And I also know that the slices are parabolas when I look that way. And when I look this way, it's rising up. And the slices this way are parabolas. But it approaches 0 here. So this is just very strange what's going on. Now let's do the other ones real quick. When z equals -1. This might be tricky. So when z equals -1, I've got x squared minus y squared equals -1. But I'm going to rewrite that as y squared minus x squared equals +1. And see that it's this. You want to have a positive number on the right side for hyperbolas. So here, this goes through when y equals 1 and x equals 0. There's height 1. Here's height 4 when I go through 2. Here's height 1 when I come through here. Here's height 4 when I go through there. But that's -4. That's -1. That's -1. And that's -4. So what happens when I look along the y-axis? What is the ground doing? If I'm standing here, what's the ground do as I look in that direction? Sinking. Ground is sinking. So as I stand here, so I'm right here, There's my freaking camera. Get everything janked up. As I look out this way, things are going down like this. As I look this way, things are going down. As I look that way, things are going up. As I look that way, things are going up. It's called a saddle point. And you've been on them if you've ever been on a mountain. At the top of a mountain, on a mountain pass, you're at this spot where the ground goes up like this. There's the mountain over there, there's the mountain over there. But down to the sides, there's these passes down this way. Right off the edge is the mountain. Think of a horseback. Think of a saddle. That's where this word comes from. So this thing here is actually, this is actually called a hyperbolic paraboloid. And I want to pull out for the last bit here Desmos. And just see. And I think Cormac's had Desmos out. Is that right?
Yeah.
That's good. I hope that's what you have out there, my friend. I don't want to know otherwise. Yes, I see it. I see a hyperbolic paraboloid rotating. And there's no computer in this room. Is there USB-C? Okay, I can do it on my phone. I can't do it on my phone. Okay, that's the end of the recording. That's it, Othman. Go to Desmos, plot this. Peace out. Done.